Hello everyone. So today let's solve the problem number 399, evaluate division, right? So let's see what the question states here. We are given equations like, so just give me a second, let me write it over here so that we understand this one even better. Yeah. So we are given equations like a comma b, a by b, sorry, that is equivalent to 2, right? Also b by c, that is equivalent to 3, right? So a by b equivalent to the 2 and b by c equivalent to the 3. For each query like a by c, so for each query like a by c, we must compute its value using given relations. Given relations, this one, right? We are given equations like a by b 2 and b by c 3. For each query like a by c, we must compute its value using the given relations. If the relation is unknown like a by e, suppose if the relation this one a by e is unknown, right? So we have only a, b and c here, right? So if a by e, if the relation is unknown like a by e, in that for that case we have to display, or we have to go with we have to return minus 1.0, right? So we can represent variables as nodes and the ratios as weighted edges, right? So just remember this, we can represent variables as nodes and their ratios as weighted edges, right? Then we can just make use of the this one, DFS, to solve this particular problem. So basically problem is this one. This is it actually. We are given equations like a by b 2.0, b by c this one 3.0. For each query like a by c, we must compute its value using the given relation. If the relation is unknown like a by e, we have to return minus 1 in that case. Yeah. So this is it for the question, right? So let me come to the first one here. See, a by b, b by c. Let's do one thing. Let's directly discuss the approach itself by considering the first example. Then you can just try it out in the same way for the example 2 and the example 3 respectively. Yeah. So let's consider example 1 here for the approach. So first thing I want to tell you here is we will be making use of the DFS, or we will be going with a DFS traversal to solve this particular problem. Yeah. So just remember this one. Yep. So here, let's consider the same first example here, this one, to solve this particular problem, right? So first we have the equations A, B, B, C, right? So values we have 2 and 3, right? And queries we have AC, BA, AE, AA, as well as the XX. But we have the relation only to the A to B and B to C. Just remember, A to B, they have given this one 2.0 value, and B to C, they have given 3.0 value, right? So first we'll be building a graph, right? So A to B is nothing but 2 0 here, right? It's A to B is nothing but the 2 here, right? So I can just write it in this way. A to B value 2 here, right? So 2.0, right? And B to C here 3.0. B to C here the value 3 actually, right? So B to A, for B to A, this one, what we'll do for the B to A, what we will be doing. So here, this one, this part actually, B to A, we will be going with 1 by 2.0. And for this one, C to B, actually, we will be going with 1 by 3.0. Right. So just remember this one. Yep. For each query, for each query, so what are the queries that we have been given here? A to C, B to A to E, and let me delete this one entirely. Now we have the idea on this. I hope you have the idea on this, whatever I have written, right? So this is fine. We have B to A to E, A to A, and X to X, right? So first, let me do one thing. Let's see. Let me consider this one. For A to C, A by C, we'll be going with A to B to C, right? So I had drawn the graph actually. For A by C actually, so this one, let me draw this one actually. Yeah, so we will be going with this one, A to B to C, right? So for this one, A to C, we have to move from A to B and then B to C, right? So this one will be, I wrote the value here 2.0 as well as the 3.0, right? So this one will be 2 into 3 basically. Yep, 2 into 3, that will give us the value 6. So here we got the 6 like that in that way itself. Yeah, the first one output we got here, right? And also for B to A, we went with 1 by 2.0. Just remember this for B to A actually. Yep. And for C to B, we have went with 1 by 3.0 actually. So this is for C to B actually. Yep. Just remember these two things. Yeah. So next we have B by A actually. B by A. So B by A is nothing but 1 by 2.0. So this one 1 by 2.0, which will lead to 0.5. Yeah. Next we have 1 by E. 1 by E, we have the relations or the equations only A to B and B to C. E is not present at all, right? So in that case, we have to return -1. They have strictly mentioned in the question. So we'll directly return -1. That is one case, right? So this is fine. Next, we are going with A by A actually, right? A by A is nothing but A by A will directly same node, right? So same node, we will be going with a +1 actually, right? And the last one is X by X. X by X, we don't have this one. What do we call? The node X at all here, right? In this case, it is undefined. So again, no path or undefined, what we have to return? We have to return -1. We'll be going with a -1 directly, right? So this is how we got the output 6.0 or 6.5 -1, 1 as well as the -1, right? The same thing, -1, 1 as well as -1. Yep. So see here, whatever the output that we have got actually is exactly same as the output that they have mentioned for the example one within the question. So our approach works absolutely correct here. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. Yeah, just give me a second here. Done with the approach part. So let me do one thing. Let's quickly discuss the complexities part here. So what would be the time complexity here based on the approach that we discussed actually? The time complexity would lead to this one, big of n plus q into e, right? I can just write it in this way, big of n plus q into E, right? So this is fine. So what would be the space complexity here? The space complexity would lead to big of n. So the time complexity would lead to big of n plus q into E, because we have n edges to build the graph and DFS for each query, as we are going with the DFS actually, and DFS for each query visiting at most all the edges once would lead to big of n plus q into E, right? So what would be the space complexity here? The space complexity would lead to big of n for storing the graph and visited nodes, right? So overall space complexity would lead to big of n. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n plus q into e and big of n respectively. Now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Let's start writing the code. So the first thing here would be this one. What do we call? Building the graph actually. First, let's build the graph using the hash map. Note one thing, each variable points to its connected variables and ratio value. Yeah, so I'll do one thing. Let me go with map here. Mm, let me go with the string again. Let me go with one more map here. So this one actually string along with the value double actually. This is fine. Yep. Let me close this one. Mm, this is fine. One second. Just give me a second here. Double. Yeah, this is fine actually. I'll just consider the variable name g here. New hash map. Yep. So the next value, sorry, let's move on with the further things here. Let's move on with a for loop here. So this one will be for int I equals 0, I less than equations we have to consider, right? So I'll just go with the size of the equations here. Yep. So this is fine. And let me increment the I. Yeah, we're done with this part. So within the for loop, so let's go with the string A, string B, as well as the value, right? Which is of the type this one, double actually. So I'll just go with the A equals, let me go with equations here, dot get of I, this is fine, and dot get of 0. Yep, so this is also fine. Next, let me copy this one. Let me paste it over here. Let me paste it over here. So let me change this one to the variable b. So this is fine. Get of instead of 0, I'll just go with the instead of 0, I'll just go with 1. So string instead of the string a here, I'll just go with a val here. So this is fine. Let me go with double actually. Let me go with double. So this one has to be values of I. So I'll just go with the values of I. So let me do one thing. I'll just go with values of I. Yep, so this is fine, man. So next, let's do one thing. I'll just go with g dot put absent. Sorry, not put absent, put if absent. Yep, so sorry. This is fine. Put if absent. So I'll just go with a comma new hash map. Yep, this is also fine. Let me give semicolon or else we'll be getting the error. So let me copy the same thing and make the necessary changes for the B actually. So I'll just change this one to the B. So this remains, every other thing remains same. Yep. So now let's move on with the further things. So we have to go with A to B is equivalent to the value and B to A is equivalent to the 1 by value that we considered, if you remember, right? A to B, if it is A to B, we went with the value directly. And if it is B to A, then we went with 1 by that particular value, right? 1 by value actually. So that one, how can we articulate in the form of code? So this one, G dot get of A, G dot get of A dot put here of this one b comma value, b comma value, right? So this is fine. So next thing, let me go with c dot get of here. I'll just go with a b actually. Let me go with dot put of a comma 1.0 here by value, right? So this is fine. Yep. So next, let's do one thing. I'll just come out of this one entirely. Yep, let me come out of this one entirely. Now let's go with the second step, nothing but we have to prepare the result array here, right? I'll just go with here double. Let me go with the result value res here, new. Let me go with the double here, queries dot size. So I'll just go with the queries here, this one queries dot size here, right? So this is fine. Yep. So the next one here would be double result equals new double queries dot size. This is fine. Let's move on with the next step, nothing but we have to process each query. When I say we have to process each query, let me move on with let's move on with the for loop here. Int I equals 0, I less than query size, this one queries dot size here. This is fine. Let me increment the I here. So within the for loop, let's do one thing. I'll just go with string src, nothing but the source here. So this one will be queries dot get of I. This is fine. Dot get of 0. Yep. So this is fine. Next again, let me copy the same thing and make the necessary changes here. Just give me a second here. String src, instead of the source, I'll just go with a distance actually. Yeah, dst. Yep. Not distance, sorry, destination. Sorry. Yeah. So this one will be same thing. The value here we have to go with get of 1 actually instead of the get of 0. Yep. So this is fine. So the next step, what we have to do, if the variable is not in the path, then we have to return -1. That is also one of the conditions that they have given in the question. Yeah. So let's write the simple if condition for it. Not g dot. I'll just go with the contains key here. So of source actually, source, or I'll just go with g dot again contains key actually of destination actually of destination. Then I'll just do one thing. I'll just go with result of I equals -1.0. Result of I equals -1.0. Yep. So this is fine. Else if, so I'll just go with source dot equals of, I'll just go with a 1 second. I'll just keep t here. Sorry. Yeah. Now, so if the same node, then we have to go with the division by itself. That will be equivalent to the 1 itself, right? So we have already done this one by considering the example 1. So I can just write it on this one, this cell. Sorry, in this way. Result of I equals 1.0. The same number will be divisible by itself. So we'll get the value 1 itself. Yeah. So next one, else. So I'll just go with here. Mm, so we have to use the DFS to find the path and the product, right? So I'll just go with a hash set here. I'll just go with string. So this is fine. Let me go with a visited variable new. Let me go with hash set. This is fine. Let me go with hash set. Yep. So the next one, result of I, nothing but the result variable we are using. So let's go with the DFS here. So here, before writing the DFS here, let's do one thing. We'll just go with the helper method DFS. Then we can just make use of this DFS within the main method, right? So let's go with the DFS helper method just to find the product path here, right? So I'll just go with private double. So let me go with the DFS actually. Here I'll just go with string src as well as the string. So this one will be the destination. Also, let me go with the map of string. So this is fine. String, comma, again the same thing. Map of string here along with the string. I need double as well. Yep. So let me go with a double. Let me close this one again. So this is fine. Next, what are the other things? So variable name I haven't mentioned yet. So just give me a second here. Let me go with the G here. So this is fine. Next, let me go with the set actually. So let me go with string here. Let me go with string. Also this one visited along with it. Let me go with a double char, right? So why 1 second? So did I give 2 times here? Angular bracket. So this is fine. Angle bracket, sorry. Not angular bracket. So this is fine. Next, let's do one thing. So within the DFS method, so if we this one reach the destination already, we have to return the accumulated product, right? So let me go with if condition source dot. So I'll just go with equals here. Source dot equals of destination. So then let me return here current, right? So this is fine. The next step would be we have to explore all the neighbors. So let me go with a for loop here. So this one will be map dot entry, right? So let me go with a string here. So I'll also go with a double. Let me go with a double as well. So this one will be a g dot get of source nothing but src dot entry set. Yep. So this is fine, man. Yeah. Now let's do one thing. I'll just go with a string next equals e dot get key. So I'll just go with a get key here. Yep. So let me make this one capital K. This one is fine. Yes. After this, let me go with a simple if condition here. If not of visited dot contains actually of next. So then let me go with double here. We have considered answer variable ANS, right? So this is fine. 1 second, man. Did I miss anything here? Yeah, let's recurse. This is fine. So this one will be next. Also destination. We need G. Again, visited. We need current as well. 1 second. So this one has to be E dot get key, right? So this is fine. Current. Let me go with a double R here. Current. So this is fine. Into E dot get value actually. Yep. This is fine, I believe. Next. Next, let's do one thing. Let's go with a simple if condition here. If answer not equal to minus 1.0, meaning infinite, sorry, undefined or this one. If it is not possible, then also we have to go with a -1, right? So if answer not equal to minus 1.4, then we have to return answer itself. Yep, that's one ANS variable, the result variable that we have considered. Else we have to return this one -1. Yeah, -1, right? If no path found or infinite, this one undefined, sorry, not infinite, then we have to go with a this one -1 actually. So this is fine. Yeah, next let's do one thing. I'll just go with DFS of this one. What do we call? Source. Let me go with a destination. Let me go with the variable G. Let me go with visited. Also, let me go with 1.0. right? So the final one, I'll just go with here. All we have to do is we have to return the result, not here. 1 second. Yep. Mm, so let me return result actually. So this is fine. I format the code once and let me hit the, so let me hit the submit button directly. I wish this works, man, directly. Have hit the submit button directly. Oh, I have not given semicolon here. Line number 26. Yes, this is fine, sir. Then what I have to do? 36 error identifier expected. Double care. So 1 second. What's wrong here? Mm, Oh, this is not care, man. Okay, correct. So this one we're making use of this one, right? I don't know why I gave care actually. 36, the same thing. Yeah. Now let me hit the run button. I should have hit the run button itself first. Still have the error. Identifier expected. Mm, what's wrong here? 1 second. I'm just going. Oh, okay. That has to be string source here. I have given comma here itself. Yep. Let me hit the run button again. Sources of the type string. Runtime error. Okay. Queries. Okay, let's check what we have done wrong. So yeah, what mistake I have done here is so within this one actually DFS helper method. So we have to add the current visited node to the VIS, right? Or else quite obviously we'll be getting the error. So I'll just do one thing. I'll just go with visited dot add of current. Yeah. CURR is the variable name that we have considered. So let me hit the run button. Now this has to work actually. Let's see if we have any other error. Mm, Incompatible types, double cannot be converted to the string. Okay. Mm, Double, okay. We have considered double. Okay. So this is fine. So where have I considered this one as string actually? Oh, did I add current here? Sorry. Source we have to add, not the current actually. Sorry. Let me hit the run button. Now this has to work. Yeah, the sample test cases are getting passed. So let me hit the submit button quickly. Sorry, I got confused here. So we have to add the source, not the current. Yep. So this is fine. Now all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.